This is my Amiga 4000 from eBay. In the last video we got this working by repairing the battery damage. Did take quite a few patch wires, and let's just say I was rather surprised when it posted. But when I bought this, I got chatting to the seller and he very kindly also included this CPU card, an A3640, although the catch is this also doesn't work. Now, someone has had a go on this before. There are a couple of patch wires that I can see, and it's been recapped, although when plugged into this machine, it won't even try to turn on. The PSU won't even start. So something is significantly wrong, and that will be the focus of today's video. Can we get this repaired? Before we do that though, it seems that I might have made a little mistake on the A4000 board, so I want to put that right first. These two capacitors, C433 and C443, I installed these just as per the silk screen markings, but I was meant to install them the opposite way around. In typical Commodore style, they got the silk screen markings wrong here. Those two caps need to be reversed, and for anyone that did see the last video, well, that explains why C443 there, why the original capacitor that was in that location, why it was exploded. In fact, if we power the board up, I can show you this on the multimeter. So we're currently in DC voltage setting here, and if I just go across this from positive to negative, that being the positive side, on the side with a solid line being the negative side, well, you can see there that there is a negative voltage flowing through that. That's not right. That is stressing that capacitor. Same with the other one. It has a negative voltage flowing through it when installed as per the silk screen markings. So need to get those two off and get them flipped around to avoid any potential explosions in the future. And with those reversed, if we just power the thing up again and measure across them according to their polarity, we can now see that that is a positive voltage running across that one. Positive voltage running across that one. That's right. Those caps will now behave properly and hopefully won't go bang. But while we've got all this out and everything hooked up, let's just show you what this card's doing. So if I take the BFG out of here, as I said last time, that's the debugging version of the BFG. That's why it's hanging out this way to allow me access to all these components. Because the CPU card normally goes in like that. Before we do install that one though, we do need to change those two jumpers to the internal clock position. Let's get this ribbon out of the way. It is those two jumpers. Currently in position 1, 2, they need to go to position 2, 3. CPU card then goes on here. I'll not worry about connecting that ribbon cable again, because when we push the power button this time, PSU fan spins for a split second and then just stops. Something on there is stopping this machine from even trying to start. Let me get you a better picture of that. You can see the fan is currently stationary, but if we try to start the 4000, gives a quick spin, but nothing happens. It's almost as if this PSU is going into like a protection mode, as if it's shutting itself down. Now that would make you think a short. So let's test that on this power connector here. Just going to get everything else out of the way first. Right, the obvious one would be between 5 volt and ground. That is the 5 volt pin. The two above it there are ground. And it's sitting there at 32.67 ohms. Now, let's pull this off. It doesn't really change it, does it? So I don't think that's our problem. Now, when we measured this previously, shut that up for a second. Now, when we measured this previously on this board in the last video, it was sitting at about 150 ohms. If we just remove all the RAM sticks, no, that doesn't affect it. In fact, I'm just wondering, when we did measure it in the last video, that was before any of the electrolytics were fitted. So maybe they are having an impact on it. In any case though, you know, the machine works fine with the BFG. It doesn't work with that. So I don't think that 30 odd ohms there is the problem. I don't think it's that which is causing the PSU to not start up. Now the other power rails on this are positive 12 and negative 12. That is those two. But there's nothing shorted on either of those. So that just seems weird to me. What else could possibly stop the PSU from starting? There's that up to like 47 ohms now between VCC and ground. Let's just see what that measures actually if I put the BFG back on here. And yeah, it's more or less the same, so I don't think that's the problem. It has to be something else related to this, because we otherwise, you know, it's the same board, everything else is the same. So what on this is stopping the power supply? Now, one of the things that stands out on this board is that it's previously been worked on, it's previously been recapped, but those capacitors were changed for ceramics. There should be 4 electrolytics on this. No, sorry, 5. 1, 2, 3, 4, and 5. Now, much like on the A4000 board itself there, several of those electrolytics are marked wrong on the silk screen. They do need to be reversed. But they are supposed to be electrolytics. They're not supposed to be ceramics. Now, I know it's quite popular in certain retro computer circles to replace electrolytics with ceramics. I'm not a fan of doing that though. Ceramics behave differently to electrolytics. I mean, there's a reason that Commodore fitted the different types of capacitors to this board. If they just had to use ceramics, believe me, they just would have used them, and there are any amount of ceramics already on this. Electrolytics are there for a reason. So I think the first thing that we'll do is take those 5 off and we'll replace them with the correct electrolytic capacitor in the correct orientation. Now, the one thing that jumped out to me there while removing those was that fishy electrolytic smell. This board obviously had quite a bad spill of electrolytic in its past, and it's obviously still covered in it. That stuff in itself can be conductive when there's enough of it spilt on a board. So, I mean, there is a chance that that itself is the issue here, why the machine is not starting. You can see that things are quite green up around here, in particular around U214 and 402. The legs of 402 in particular there are rather nasty looking. So I think what I might do here is just quickly try and reflow those 2 ICs in particular. Maybe U205 there, oh sorry, 215, as it's looking a bit nasty on that side, and perhaps U220 as well. In fact, just looking at the board here, it seems that U204 and 209, 2 gals, it seems that they have at least been reflowed in the past, if not possibly changed. And there's a pad missing, just in there. I'm not sure if you can make it out on the camera, but just that last pin on this side, the pad is missing. So potential problem there. And I suppose it would be worthwhile just double checking that this patch wire here has been installed in the correct location. You know, it's running from that pin on U221 down to this pin on the CPU slot. But is that correct? I'm sure it is. I mean, why else would someone have put it in like that? But it's always worth double checking when you get a board not working that has been worked on in the past. Taking a quick look on the bottom side, there's not really any signs of rework down here. A couple of bent pins on the back of some of those 3-hole packages, but I don't think there's anything there shorting out to anything else. The CPU connector itself, yeah, it's a little bit crusty looking. So we'll spray a bit of contact cleaner in that. And is that damage there? No, I think that's just dirt on the PCB. It almost looked like a scratch across the trace. That, however, is a scratch across the trace. There's definitely a little bit of damage just there. Say the trace runs from that pin across here to a via there. It does continue on down the board, but we can measure it to that via and it buzzes out alright. So it's just superficial, whatever that scratch is. Another little scratch on the PCB there, but again, it's very minor looking. I don't think that would cause any problems. And yeah, that's me measuring either endpoint of that trace that has that little scratch in it there, and it's fine. No issues. Right, going to reflow a couple of these components here. And it absolutely stinks. It is nearly making me choke. Excuse me. That is strong. You know what? We'll just mix a bit of clean solder into these, and I'm going to remove those ICs so that we can clean up underneath them properly. And in fact check continuity of the pads, because that has been a rather significant spill of electrolytic. It absolutely stinks. Right, that's those four off. And yeah, there has been quite a bit of corrosion there. You can see it in the flux that's left behind. So let me tidy all that up, and then we'll just inspect around those four ICs, just in case anything there might be damaged. I cleaned up really well, and certainly from a visual inspection, it all looks good. I don't see any obvious signs of anything broken, but we will just check it. Now, if we were working on an Amiga, we would use the likes of PCB Explorer to help us. We don't quite have that option here, but we've got the next best thing thanks to Chucky. Because a few years back, he stripped down one of these boards and drew the whole thing up in CAD, and we can view it here in Sprint layout. Now, it does look like a bit of a mess there, but I can turn off the internal layers that we don't need. It's just an internal ground plane and internal power. And then if we take, for example, U220, and we can see pad pin 1, and the trace coming from that, if we just select that trace, it highlights it and it shows us where it runs to. We can follow it across the board. It ends up at that gal on that pin of it. So pin 1 of U220 should be connected to there. And it is. That's fine. Escape just deselects it, and then we can pick up on pin 2. Little bit of a tedious job, but it's going to be necessary just to be sure that nothing's broken. That connection's okay, and we can follow this right across the board, and it runs to that pin on one of the gals. Again, that's fine. Okay, I've been right round all four of those. Everything's fine. But I suppose what we should really do is check this patch wire, check that's in the correct location, and maybe just check around that actual IC. I mean, that patch wire was put there for a reason. Maybe the corrosion from the caps got down onto that chip and caused damage there. Maybe there is further damage around it. So that is U221. And the patch wire there is on the 4th pin along on that top side, which is that trace. And it's connected to that 3rd row of pins there. Working back from that joint, it is the 11th pin back. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, that is connected up correctly. And that's fine. Just going to check around the rest of that IC though. Yeah, that's all okay as well, so I guess we should just go ahead and refit those 4 ICs along with the 5 electrolytics. While we're doing this though, remember that gal there, which I said had a pin missing, or a pad missing? Well, it definitely does have one missing, but if we take a look at it on Sprint, We can see there that there is nothing connected to that pad. So the fact that it's missing shouldn't cause any problems with this machine trying to work. There's a little bit of repair work here, but everything does buzz out okay. And I know I said earlier that there was no signs of any repair work on the bottom side, and no signs of anything having been reflowed. That's not right. Resistor pack there, that has definitely been reflowed. And in fact, it's actually sitting out of the board ever so slightly. Don't know if you can make it out at this angle on the camera, but I can see here where it has been lifted up slightly. I did test right along that though, and it's all fine, making connectivity to wherever it needs to be. So yeah, a bit of a loss. I half thought we would have found something broken there, something that might have explained why the machine won't even turn on. There is a jumper here labeled do not remove. That jumper is J100, but it is handling the clocks. It takes the clock from the crystal via U101 here and back to the CPU. So nothing to do with that. Let's get these chips back on. Let's fit those electrolytics. The 5 caps that we need to fit, they're all 22 microfarad, but as I said, a couple of them are back to front. 3 of them, in fact. Now, Chucky has corrected it on the Sprint layout. It is capacitor C106, 105 and 107. We take a look at it here on the board as it is. Positive side of it there, C106, is denoted as the bottom. And if we go to one of the 7.4 series chips, the positive pin on that, or the VCC pin, would be the last pin on the package. That would be that one. But as you can see, there's no connectivity there. If though we go to the ground pin on our chip here, which is that one, you see that that is making a connection there. If we take our probe and put it onto what's supposed to be the ground pin of the cap, according to the silk screen, and go back to the VCC pin on our chip, well, as you can see, that one's backwards. That one's backwards, as is that one, as is that one. Those two, C102B and 102E, those two are in the correct orientation. I was very nearly going to put that one on the wrong way around, as in put it on the way it shows it on the silk screen. It is so counterintuitive doing it like this, doing it the opposite way to the way it shows it. Even though I know I'm putting it on right, it just seems weird. Okay, I'll just clean all the flux up there, and then I think we'll test it again. I don't think this will make any difference because we haven't really done anything, have we? I mean, we changed those ceramics to the proper electrolytics, but that in itself wouldn't have been enough to stop it working. Yeah, the ceramics fitted there are a bad idea. It's meant to be electrolytics, but that in itself wouldn't be enough. And yeah, it's still just behaving exactly the same. Power supply gives that quick blast from the fan and then just shuts down. It is almost as if this thing is protecting itself. It's behaving as if there is short. Now if we bring in the multimeter, and let's take another look at that between VCC and ground. 24 ohms. You know what? I'm wondering if the problem here might actually be with the motherboard, because that number has dropped off again. In the last video it was about 150, and when we tested this earlier it was sitting at 30 odd, and then I think it got up to what, about 50 ohms. So I'm wondering, is there another failed component on this board? Wondering why I couldn't fit that. That's because it goes on that way around. I'm wondering, do we maybe have another failed ceramic? Doesn't really explain though why it seemingly starts with the BFG in there, yet doesn't start with this. What I'd like to do is let's have another look at the bottom side with the thermal camera. Okay, it's been running here for a couple of minutes, so everything should be nice and warm. And straight away there, check it out, right in the middle of the board, there's something there sitting at about 45 degrees. I think that's that capacitor, C103. Could our problems here be that simple? In fact, that's up to about 50 degrees now. Could this be another shorted capacitor? If it is, I'm not really sure why the machine starts with the BFG and won't start with this, but it does warrant some investigation. Take a look over the rest of it though. I think those hot spots that we're seeing there, I think those are just vias. Or possibly those resistors actually. Those resistors are warmed up a bit. A lot of this slowing on the back that we can see here, that's just from components fitted to the other side. I mean, down here, this whole section of the board looks very warm, but Alice sits on the other side of the board, just about there. There is a component there though that is lighting up. Although that is a resistor, R178. Maybe just test that, just to make sure that it is reading correctly, because it does seem to be getting kind of hot. And down in this corner, there seems to be 3 bright spots. One just there, which is another resistor. One there, which is also another resistor. And then one there, which is another capacitor. So possibly 2 caps that we should check out. Moving across this way, a couple of other bright spots. There's one there. That's a cap, C352. So yeah, that one might want investigating. Not a bright spot there, but that's just a via. Right, so the 3 caps that we need to investigate: C103, C352 and C990. If we take a look on PCB Explorer, just on the bottom side of the board here, C103. Yeah, that is a 100 nanofarad decoupling cap between VCC and ground. C352 then. Yep, that is just the same thing. 100 nanofarad between 5 volt and ground. And then C990. That's the one just here that I couldn't make out the silk screen writing. But it's C990, and again, 100 nanofarad between VCC and ground. Let's get them off. And so the big question then, are any of these shorted? C103. Yep. C352. Yep, it is shorted as well. And C990. I think that one was okay, but it just went ping. Yeah, we'll just replace it anyway. Save me hunting for it. Nope. Fan spins for a split second and then gives up. Well, this seems odd. I was having a poke around with the multimeter and I noticed that the 12 volt rail is a little out of spec because it's sitting there at about 13.5. A little high, perhaps a little too high. What could be causing that though? So I thought to myself, is the PSU maybe not loaded correctly? That's a modern ATX power supply, well, modern-ish. And you know, it's expecting to power a motherboard with these 12 volt rails, you know, for your modern A3640 CPU. It even has a plug on it for a modern GPU. So we're not really loading the PSU here the way it was designed to be. Got me thinking though, what would happen if we just disconnected that hard drive, which I have there, you know, just for a bit of load. What happens if we disconnect that? Well, it starts for a split second and then shuts down. So here's what we're going to do. We'll reconnect this hard drive, but let's connect another one. I have an old Maxter 40 gig drive here. System powers up again. What is that 12 volt rail doing now? Both hard drives have started. It came down a bit, 13.1. I suppose we could further add some more load. Now the only thing I've got to add more load is yet another hard drive. An old Quantum drive. This one's really old. It's only 170 megabytes. Don't even know if this drive works, to be honest with you. Well, it works, but it doesn't sound too healthy. The spindle bearings and that there must be kind of dry. The drive is squeaking away. Well, that's brought us down now to more or less 13 volts on the 12 volt rail. Still a bit out of spec, but with all that additional load on the power supply, is that going to make any difference when we fit this CPU card? It starts. I don't believe it. Oh, no way. Just on a black screen though. Oh, no, actually scratch that. It's booted. I don't believe that. That has sent me down the rabbit hole there. Seemingly nothing wrong with the CPU card then. Just wanted those caps swapped. You know, I would have done that anyway. But the whole reason it wasn't starting is because my power supply wasn't loaded enough. Let that be a lesson. Some of these modern ATX PSUs aren't really suitable for the Amiga. Those things are more designed to be putting their load on the 12 volt rail. Very little these days is drawing power on the 5 volt rail, whereas all of this is 5 volt. Let's just take a look at the voltage rail again now that she's up and running. Still a little high there, at 13.2, 5 volt rail. Well, it's sitting a little high as well, 5.06. Not that that would give me any cause for concern. I would definitely prefer that 12 volt rail though to be, 12.5, 12.6. Just being over 13, I mean, it's bordering on 10% higher than spec. I don't think it's going to cause any damage to the likes of a hard drive. Could potentially damage any components that are relying on that 12 volt power rail though. So I think I'm going to have to try and find another PSU, but in the meantime, let's hook up the floppy drive again and let's see if we can boot the Amiga test kit just to confirm that our CPU card is working as we suspect. So boots up. That Quantum drive is sounding worse by the minute. I think I'll just have to disconnect it. But into Amiga test kit, it is confirming there that we have our 68040. The memory is just as is on the board now. There's no fast RAM on that CPU card. So it's just got the 2 meg of chip and the 16 meg of fast. I'm going to leave it testing the fast RAM. We'll leave it there for about 10 minutes or so, just to be sure that everything is stable. Certainly seems to be, but just want to give it something to do for a minute to try and confirm that. Okay, so it's been going there for just over 10 minutes. Seems fine. So how about we try a couple of things that we didn't do last time with this A4000. We haven't tried the boot to its IDE port, and we haven't tried anything in the Zorro slots. I found this other PSU, and despite the fact it's one of those that's so light you would swear there's nothing in it, it's only 300 watt, but it seems quite happy to run the 4000 here. Still have the 40 gig Maxter hooked up there just for a bit of load on this, but we're not using that drive to boot the 4000. Instead, we're going to try and use this CF card. Just pulled that out of my CD32. It was booting to Xbench, but I've disabled that. It should just boot into Workbench. We'll test it there, and then we'll test this Zorro card, see if we can boot to this. It's an AT bus clone. This gives you an IDE port, but should work okay on the 4000. So internal IDE first. Hopefully you can see the access LEDs on the CF card adapter. Green just means that the CF card itself has been detected. Yellow, that's the one we're interested in. That's the activity LED. Red just means it's power going to the CF card. So let's see what happens. We are seeing a bit of activity there. Will it boot? Looks like it's trying. But no, it has just dropped us to the kickstart screen. That's odd. Hold on till I plug in a mouse. Because if we hold the two mouse buttons while we power this up, we should get to the early boot menu. There we are. And if we look in boot options, yeah, there's a hard drive. The CF card is partitioned into 3 drives. DH0, 1 and 2. DH0 being the bootable drive. That's obviously what it's trying to boot to there. Can we force it to boot to that drive? Again, the access LED is flashing away. But no, it just gives up. That seems odd. How about we try it in this? Now on this board we don't need to power the CF card adapter remotely. Rather, this thing supports key power. You can see it's jumpered there, and that provides power to this through the key pin. You know, the pin is normally blanked off in the middle. In this instance, that's providing power to run our CF card. So this will go into the Zorro slot. I'll just stick it in the top slot. And let's see what it does now. I'm just going to put that floppy disk under there, just so that you can see the reflection of the LEDs. Access LED is flashing away. And this time it has booted into Workbench. Now ignore that DFO 0 question mark. That's just because I don't have the floppy drive connected at the minute. But yeah, it has booted. Oddly, it isn't detecting all the RAM. It's only detecting 2 meg of fast RAM. I don't know if I have an Amiga test kit on this, or even sysinfo on this. I don't think I do. No. Let me hook up the floppy drive. Oh, I see why it didn't detect all the RAM. That power good or fail signal that has fell off and I didn't notice. Now, you may wonder, what could that possibly have to do with fast RAM? Well, that fail signal actually resets RAMsy on the motherboard, which deals with the fast RAM, and without that connected, the fast RAM itself will not be properly detected. But look, we will just connect up the floppy drive anyway, just so that we can run the likes of sysinfo. Back in the Workbench, no DFO error this time. It is indeed seeing all the RAM now. Let's just run sysinfo. It is correctly detecting our 68040. Shall we do a speed test? And there we are, right in line with what's expected for an A4000, or well, an A4000 with the 040. We can take a look at memory. There's our 16 meg of fast, 2 meg of chip. Hard drive speed, 1.5 megabytes a second. I don't have a lot to compare to in terms of A4000 performance. That is a Zorro 2 card, so perhaps won't run as fast as it potentially could, but everything does seem to be working okay. We can of course give it something else to do, perhaps something to test the hard drive to stress it a little bit. Let's try a bit of Avenger. This game does hit the hard drive quite hard as it's loading all the data for the video. Drive is working away there, so I think we'll just leave this intro to play for a minute, although it does seem that everything is working correctly, or well, working correctly from the Zorro card. You need to figure out why it's not working from the onboard IDE. Hopefully that little test confirms that the Zorro side of the 4000 is working. Now, as I said, that is just a Zorro 2 card. I don't actually have any Zorro 3 cards. Okay, that's a lie. I do have one Zorro 3 card. Remember the IDE, LAN and clockport card? It can be reflashed as Zorro 3. It is currently just flashed as Zorro 2 because it lives in the 2000. Just be a bit of a faff to reflash that at the minute. But since this works, I think I'm happy enough to say that Zorro works. Do want to try and figure out the internal IDE here though. Why does it not work? Although things have moved on slightly, because if we try and power it up now, we get a yellow screen. So that would make me think there is definitely something wrong with the IDE side of the board. In fact, when it does power up now, does get beyond the yellow screen and continues to boot. But when it does, and if we get into that early boot menu, you can see that the drives are no longer there. They were definitely visible not 10 minutes ago. So I don't know what's happened there, other than the fact I have turned this board around to give you a better look at the IDE side of things. That in itself is controlled by these two gals here, U901 and 902. And then there's a set of 245s at 903 and 904. Now, I was initially suspecting the 245s, since it did try to read and then sort of fell over. But considering now that the entire IDE side of it has fell over, I think it's more likely going to be those gals. Now, unfortunately, I don't have any spares for those. I don't even know if I have any means of writing to those. I can do it on the TL866. I just don't know if I have the adapter to mount the PLCC20 chips. That is the smallest adapter I have, but that is for a 28-pin chip. Those are 20-pin, so it looks like I'll have to order an adapter. I do have the 245s in stock, and it wouldn't take a lot to swap them. And I suppose it might be worth even just reflowing around the two gals. And maybe there's a dry joint there somewhere, and that's why it sort of worked and now it doesn't work at all. Me moving the board might have upset that. In fact, let's just push on those two chips. Hey, started this time without the yellow screen, and it is starting to try and read again. Granted, it has dumped us back to the kickstart screen, but could it be that simple? Might they just need a reflow? Okay, I've reflowed both galls, but while I had the soldering iron out, thought I would just go over the 245s as well. Might as well do it. Iron was hot, so let's see what happens now. Well, no more yellow screen, so might very well just have been a bad solder joint. It is trying to read there, but again, it's just dumped us to the kickstart screen. So I don't know, do we have an issue with that onboard IDE? I want to try something. Let's hook up the floppy drive, and I want to boot to sysinfo, because if we can see the partitions on the CF card within that early boot menu, what happens if we go into drives here? Yeah, there they are. DH0, 1 and 2. We can interrogate the speed of it. There's the hard drive LED working. It seems to be working fine. Why will it not boot? Could that be some weird issue with the galls? I mean, you wouldn't think so, because if it was, you know, surely it just wouldn't work at all. But other than not booting, it does seem to be working. Although, as you did see, that CF card works fine with this thing. The ROMs on here are version 3.0, but you should be able to boot 3.1 on 3.0 ROMs. I mean, we just did do that with the Zorro card. But I wonder if I should maybe create a basic Workbench 3.0 installation on another CF card. And so that's what I've done. Created a small partition on this 16 gig card, just a 200 meg partition, and installed Workbench version 3. Let's see if that makes any difference. Activity LEDs flashing away, and yeah, there it goes, straight away booted into Workbench. Why did 3.1 not boot on the internal IDE? Why does it boot using the Zorro card? I honestly have no idea, but hopefully that confirms that the IDE on board is working fine. This might actually be the first machine of mine on which I'll use 3.2. But that is for the future. Last thing I want to do for now is try and test the keyboard port. Now, you'll not see it from this angle on the camera, but that keyboard port would remind you of a PS2 port on an older computer. And in fact, the Amiga 2000's keyboard, it would remind you of an AT port on an older computer, or an older IBM compatible, you know what I mean. So could we just use a simple PS2 to AT converter? That will definitely plug in there. Before I go plugging this in there though, I just want to check that the pinout here is correct. So if we compare this to the keyboard pinout on the EATX 2000, that's the 2000 that I built, and I'm using those schematics because it gives you a nice image of the DIN and shows us what should be going where. Now pin 1, that is the keyboard clock, but the two pins that I want to check in particular are pins 4 and 5, because pin 4 should be ground, pin 5 should be 5 volt. So if I can wedge that in there, wedge that probe of the meter into what should be ground, and no, that's not ground. 32 ohms across that. Does that sound familiar at all? That will be 5 volt. What should be 5 volt then, pin 5. Yeah, that's a dead short to ground. As I was worried, this is mirrored. I have seen some reports of these things not being wired correctly, and that definitely seems to be the case here. Nothing's ever easy. I just cut this in half, thinking I could rewire the cores of it, but there only are 3 cores and a ground. So while I probably could swap over VCC and ground, I'm not going to be able to swap over the clock pin and that other pin there, which is unused on this. I may have to get destructive, cut this up and try and get that out of there so that we can get to the terminals in the back of it to rewire it. I mean, I've wrecked it now anyway. I'm not sending it back to Amazon like that. So yeah, time to get creative. I suppose it's just dumb luck that the 4 wires going to the PS2 port side of this were connected to the right pins. So I've rewired everything going to this side. Let's plug it in and see what happens. Before I power it up though, one very quick test. That's a ground on the keyboard there. That's a ground on the 4000 and that's a dead short. I think that pin is VCC and I can pick up, see him down there. Yeah, at least 5V and ground are going to the correct locations, so hopefully nothing goes bang when we turn it on. I've got to make a test kit in the floppy drive. We'll use that just to test the keyboard. Power light comes on. And so F2, yeah. We've got a working keyboard. Awesome. It even resets. Now obviously this, I've been calling it my A2000 keyboard. It's not. This is an A500 keyboard. That's why it's got the power light there. And it's also got the floppy LED. Now on my A2000, I was able to modify the bottom of that board to pick up the motor on signal, run it through a little transistor, and that's what powers that LED. In this wire going to the keyboard, there was a spare core, so I just used that wire for the LED, for the floppy LED. I was intending to do a similar thing here, but the adapter that I have only has the 4 cores in it, so I can't pick up the signals that I need to drive this. What I'll maybe do is just try and pick up a PS2 port and I'll wire up my own cable, and then at that point we can wire in the motor on signal to run this LED. But otherwise I think that's us with a fully working Amiga 4000, A3640, IDE is good, Zorro all seems to be good, and I now also have the keyboard. Well, I think that's everything on this board now working. Granted, in this video we didn't actually do very much, did we? Other than recapping the A3640 and potentially fixing a broken solder joint around those galls. Well, everything about the 4000 just seemed to work. The other issues were just down to my own lack of knowledge playing with this machine. In terms of that booting problem, why would it not boot on the internal IDE, but it did boot on the Zorro card? Well, I'm pretty sure that comes down to the ROM that's on the Zorro card. That ROM will be loading its own device driver, replacing the device driver that's in the onboard kickstarts. That device driver obviously will load Workbench 3.1, whereas the device driver that's on the ROMs just doesn't seem to like it. Now, in saying that, I'm not really sure that makes sense, because that Workbench installation on that CAF card is actually using load module to load its own SCSI device driver. But honestly, that's the only explanation that I can come up with. It's something to do with that ROM on the Zorro card, just magically fixes it so that the A4000 can boot. The ultimate goal for this machine, as I said, I'll be installing 3.2 on it, or 3.2.2 I think the current release is, but that will be for the future, along with sticking this in a case. Now unfortunately that is going to have to wait for a while, because those things are quite expensive. I've decided that it needs to go into an original case. There are reproductions of those available over on Amiga, but it's going to cost me about $3,500 just for the case alone. I then need to get the front fascia for it, probably need to get that 3D printed, and I'm probably looking the guts of another £100 or so. So I'll need to save my pocket money before we jump in and do that. So I'm going to put this away for now. It'll be a while until I've saved up enough to buy that case. And then along with that, I will need to get a better power supply for it. I'm looking at the SFX range of power supplies. That's another £100. Nothing's cheap in this hobby. I'll need to get a couple of drives. One thing that I do have now though, and I want to say a quick thank you to Gavin. who's a local Amiga enthusiast. He called up a while back wanting me to program a couple of PALs, and he very kindly gave me this high density floppy drive along with this converter board that allows these to be used with the Amiga. That's a drive we were using throughout this video, just with double density disks, but we can use high density disks. I'm going to keep this for the eventual A4000 build into a case, since a high density disk drive was an option on these machines. One other thing that I might look at doing in the future is the A3640. Apparently we can do a modification to this to improve its performance. We can overclock it, and we can also modify it to remove a wait state so that it can access the RAM faster. That's all for the future though. For now, all that's left for me to say is thank you very much for watching. Hopefully you enjoyed this video. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already, because there's plenty more yet to come here on CRG, and I'll see you next time.